We are back. This is Hackers on Planet Earth. What an amazing few days we've had. We're starting day 4 right now. It's going to be a fantastic talk, a physical hack, something that we're sometimes in the virtual world, we're sometimes in the software world. Today, we're even going beyond the hardware world and we're getting into some big hardware. It's very exciting. Before I tell you about that, let me mention the EFF fundraiser. This is linked at the top of every Hope page, and we're going to do it today. We are going to kick that fundraiser goal into the past and work towards our next goal for the future. Hackers on Planet Earth and 2600 Magazine are grateful to all the great work that EFF has done, continues to do on behalf of our online civil liberties. The link is right at the top of www.hope.net. Let's welcome next Yoshinari Nishiki. He is an artist and researcher based in Rotterdam over in the Netherlands, has done a whole bunch of things that we'll hear a little bit about. Today is going to be all about shipping containers. Welcome, Yoshinari Nishiki.
Hey, my name is Yoshinari Nishiki. I'm a Japanese artist based in Rotterdam, in the Netherlands. Today I'm going to talk about my project Panjang Container, which is a manual system, completely manual system that allows one person to move an entire full-scale 20-foot container by themselves. How on earth a person like myself could have pulled off a project like this without any engineering background? Is that the topic of my talk? Are you ready to roll a container? Hacking ISO shipping container corner, mobilizing a TEU in a way you never imagined. This TEU, some of you may not be familiar with this term. This actually stands for a 20-foot equivalent unit, which is the most typical container that you find on the street. So what I did was to come up with a process to allow one person to move or roll an entire full-scale container by themselves. Well, why do I have to make such a system? Basically, so you may wonder, but there's a system or story behind this concept. This is the smallest container ship that you can possibly imagine, which is carrying only one container on board, and it's all to sail and zero emissions. Since June 2020, we now, 3 of us as a team, and an assistant professor, Giovanna Giovanova, and Professor Laurent Tabassi, both from Technology University of Delft, we became a team to seriously develop this concept. And basically, if there's such system carrying one container on the vessel, it means that it can come way closer to urban populations because it doesn't require any kind of port facility anymore. And if it drops off a container to a nearby waterway, you also want to carry out the last mile delivery of this container, zero emissions. There's a number of ways that you can possibly do zero emissions container transportation, or trying to sort of develop a novel way to do it. So that was basically the Panjang Container project was about. But why do I have to make such a small scale container shipping system? And that is because the current mode of shipping is becoming colossal, which means they're carrying more than 20,000 containers on the vessel. And they are basically sort of dictating as it gets clustered and it becomes bigger. That means actually there are fewer shipping companies that actually sort of dictate the whole shipping industry. We then sort of came out with this exact opposite approach to the current mode of shipping for a number of reasons. Well, one of them is to solve the trade biases between Asia and Europe or the States. Basically, there's shit tons of stock to carry from China to Europe or the States or Western country, but not much to carry back to Asia from Europe or the States. So that means actually there are a lot of empty containers being carried by container ships. But this kind of information is of course confidential because it affects the shipping rates. No one wants to share with you how many empty containers they're carrying on a vessel. But not only that, the bigger the vessel, the more costs to the port infrastructure, and this is covered by public money. So this is something that shipping operators don't pay, and then they claim that they're actually saving a lot of money. Of course you do, because you're not paying for it. So they kind of cleverly playing with the externalities, and they claim there's economies of scale in it. In fact, there's not so much benefit that you can get out of the scale anymore, according to OECD report on the impact of megaship. we urgently need to make a new mode of shipping. There's technology available in autonomous shipping, and there's increasingly a lot of discussions happening around how sailing technology from the sports sector can be applied to cargo shipping. If the vessel is so small, then possibly it can harness the wind in a better way than the bigger vessel, even if it's a cargo transportation. So that is sort of basically the reason why we're sticking to the smallest unit. But anyway, so I'm gonna carry on with this how I roll a container. So the inspiration comes from this guy called Herman Braunix from KU Leuven, which is the Catholic University of Leuven. They have quite a good engineering department. I had met him on a number of occasions at conferences in the Netherlands, and he's in micro robotics. And I was asking him, he's a professor, have you ever thought of a system that helps one person mobilize one container? And then he said, yes. But he said, at the same time, but any design depends on a lot more than just the requirement to be able to move one TEU. So it is impossible to give a summary. But I'm a kind of type of person who just keeps asking questions. So I asked him again and again, so what would the system look like? Although he said, well, he cannot give any summary. Actually, he didn't reply back to my emails, but still sort of somehow triggered my imagination, because it sounds like almost like the sci-fi. When a serious scientist says something that I thought would be impossible, it's possible. Based on that, I had a lot of imagination, and I wrote an application for arts funding from the city of Rotterdam, and I successfully secured 10,000 euros, which is about $12,000, I think, which is quite a lot of money. And I'm trying to collaborate with researchers from Belgium. So I heard this small port in Belgium called Port of Oostende. They're somehow hosting a conference on an electric boat in the south of the Netherlands. And I heard that some of the researchers from this Herman's colleagues are coming to the conference. So I joined the conference board, which was for free, to talk to them. And what happened was that they thought the amount of money I secured, 20,000 euro, was just so small. Because again, talking about the scale of funding in the scientific research and artistic research, there's a huge gap in between. So the 10,000 euro, in fact, was almost next to nothing for those researchers. So he just basically said, well, what I can do with it? I can't do almost anything with it. They actually said they were not so willing to collaborate with me, partially because of the limitation in funding, but also at the same time, the concept of moving one container to the last mile deliveries location within this limitation of one person and so on, that sounded maybe too ambitious for them or something. So I have to sort of take different approaches. I made this diagram of evolution. So I had this first system in my mind, autonomous system that follows a human like a dog. That's exactly how I wrote in my funding application, and that was approved somehow. And then there's some kind of manual system to lift up a container to this robot system so that it can follow me like a dog. But from this point, I first turned to a bike approach. So this is sort of using some lever systems and so on. I also turned to some sort of proprietary existing system combining some kind of bike and also container moving system. And of course, this is could be the most boring way, but there's a proprietary container roller that can be attached to the bottom of a container, so you can just start pushing or something. I'm going to talk about it later. And I hit this something called Panjantron, which actually this name Panjant container comes from. This is a never used World War II weapon developed by the British Army, but I'm going to talk about it in a bit. And this is how the Panjant container looks like. So neglected by researchers from Belgium, I started to look around logistics system on the street and in supermarkets and those places. And this is in a German supermarket called Aldi, so they're using such a system. I think some of you have seen such system to move around stuff to stack up shelves in the supermarket. And this is like a way of unitize some things. In this case, this is the toilets put together to form some sort of unit out of it. So it looks like a container. So you can unitize something like beers as well. In this case, 12 cans of 500 milliliters beer perfectly fit into this. And I find this banal looking tool, but when I look at it, amount of stuff that it can carry, and I was like, oh, well, it can carry up to 2,500 kilograms, which is actually 2.5 tons. An empty container weighs 2.3 tons. So this means that just using this tool, which actually costs, it's discounted $643.50. In theory, you can already carry, that was a sort of good start. Then I went to this festival in the north of the Netherlands, International Kalkbak Festival, to see this very specific system developed for carrying pallet with the bike. This is how the system works. The pallet is on the ground, and then you insert something, and you use the lever system to pull it up, and then attach to the bike. Thanks. I consulted with a guy called Ollie Palmer, who was involved with this project called OpenSail, or Prote, sailing drone that's made for collecting spilled oil on the ocean. But that was more like a kind of proof of concept, or they developed some sort of prototype, and then this guy who was mainly developing the project did a TED talk and got some sort of establishment and so on. Anyway, the Ollie was working for him as an engineer. He would be a good person to consult with because it's a related subject. And he suggested I could possibly go for some sort of bike method to move a container, some sort of using lever or so on. He made some drawings. And I met this interesting bike company called Number 5 Unexplained from Amsterdam. I visited his studio, this guy called JP, and he basically explained to me how a bicycle works and how a bicycle doesn't work with carrying a container, basically. Because in order for a bike to function, you need a certain amount of velocity from the beginning to put the bike straight. Otherwise, you need something like a tricycle, which I did not really want to use. He convinced me that a bike doesn't work. But I also saw an interesting bike developed by a Swedish company called Velov. It's also used by DHL. It's a recumbent 4 wheels bike, electric. And there's another company I found, a Swedish company called Winglift, which develops proprietary container carrying equipment. There are 4 wheels, but this basically can be divided to 4 different parts, each of which fits into the bottom corner of a container to allow the container to be basically move up and you can start carrying things. So by combining these 2 concepts, you could possibly make a system like this. And it kind of looks rad and can be cool. But at the same time, I thought, well, where's the invention in this? I'm just using proprietary systems. I'm just buying something that's already been developed by other people. That's not interesting enough for me. But anyway, both companies, the Velov and the Winglift, they did not support my project. I couldn't afford their bike or their system. So that is also the financial burden that stopped me from going into this direction. There's a horse idea of turning to animals such as a horse to pull a container, but this also didn't quite materialize. There's a company called Seabox. They develop a proprietary container caster that can be fit into a bottom container. But then a friend of mine who studied physics told me that there's too much rolling resistance to perform enough force to pull or push a container. So basically you cannot just pull or push a container because its resistance is too high. That's why I learned. And during this time I discovered this concept called punch and drum. So this was game changing because why did I not think about actually the rolling the entire thing instead of putting the small wheels underneath it? So that's like a game changing concept. This actually turned out to be a never used British World War II weapon that was meant to destroy Germans on the beach. There's a video by Imperial War Museum, and it's explosives attached to wheels and it rolls, and the explanation said that it never went straight, and therefore it was never deployed. Inspired by the form of speculation, I thought roaring could be really interesting for containers. It also could be quite spectacular if it really works. This is the very initial drawing that I made. Then also came out with the idea of using inflatables. By switching the level of air inside each bag, possibly can kind of make a sort of caterpillar-like movement to initiate some kind of roaring movement. For this project, I kind of knew from the beginning that working with scale models probably would not work, because at the end of the day, what I'm really dealing with is a real object. It's not like the miniature of the object. And in order to move a real object, the system has to function with real parts. So what I was already interested in was how real container actually looks like. So I found this container on the street of Rotterdam in an area called Koolsingel. owned by a big container shipping company. I don't know why this container was there, but I measured the whole container. And I found something interesting, which was, in fact, each container had slightly different sizing. It's due to the damage to a container. And then I thought, oh, that's like understandable, because if you carry a lot of stuff in a container, of course it gets deformed. And therefore each container had a different size, slightly different size. Like it could be a few millimeters, but it could be quite fatal if you're developing a system to roll a container. So that really made me think, well, in what way I could actually make a flexible system that can be adapted to any kind of standard container. So it kind of sounds strange, but a standard container also sort of the size varies, and that's why I also discovered. Within the container, the most important part, some people say, is the corner of a container. This is ISO certified, and it has 3 holes in a corner. And there are 2 types of different holes. The one on the top has a slightly different shape to the side hole of a container hole. A hook can go into the top and lift the container. On the other hand, the bottom container, there are 2 exactly the same holes on both sides, and then the big one in the bottom. So that's how sort of container holes actually not all the same. They're different. This image shows how a real container is being used on a vessel with something called twist lock. This goes into a bottom of a container, and if you see this lever and you trigger the lever and it gets locked, untrigger the lever and it gets released. This is how container shipping works. If you're using a crane, you can also remotely control the triggering part to unlock or lock a container. So that's how to manipulate a container at the port. So based on the scaling of a real container on the street, in order to make a sort of wheel out of a container, for me, it was apparent that I have to utilize the container corners leverage, and the best way is to utilize 2 holes out of a container corner. So I turned to this container parts company called Fandom. I asked them on the form, can I use 2 holes over 3 holes of a container corner simultaneously? And they said no. Basically, no one does. And they said I cannot do that. I just wanted to find out that if it's really the case. So they have a lot of mock container corners, and I could test how the connection could possibly work. This is the bottom twist lock, and this is the side twist lock, manually twisted to lock into a container. This is actually a wrong video, because this is using the wrong container hole. I was supposed to use the other hole. Anyway, there's another image that shows the real collect image. Yeah. It actually did work out. It just didn't collide inside. So this concept could potentially work. And this is how the bottom twist lock looks like. And this one is the side twist lock. And interesting, I also found out is that although there's a lever embedded to a bottom twist lock and it looks more expensive, where in fact the side twist lock that functions completely sort of manually, it's way more expensive. The bottom twist lock with the lever, it costs roughly 20 euros or so per piece. And on the other hand, this side twist lock actually costs more than 100 euro per piece. So I had to buy 8 of those, so it cost me already quite a lot of money. The bottom twist lock is actually made out of a different material to a side twist lock. That means you needed some foundation structure to be welded into some sort of steel structure. And this is the most basic H-beam, what they call, which my friend architect Frank Lohr suggested that I should go for. He knows, of course, all the building materials, and he said this is just so strong that it will not just collapse to carry a container. So I started to speculate on how a container could possibly be rolled, in what process, and so I was trying to streamline a process using drawings. And at this point, I finally made a scale model for the first time, specifically to see how a container can be rolled. So not to measure the weight or anything else, to how this process can be streamlined. So this is possibly the tipping point of a container rolling system.
You will learn how to discharge a container from a truck with a Type 1889 lifting system. You should use 2 to 3 operators depending on loading regulation. A mounting winch is recommended for weights over 5,000 kilograms. A simple lock into the lower ISO corner completes the attachment. The container is lifted simultaneously on both sides until it is clear of the vehicle.
In order to attach the wheels, I was pretty much sure that the container needed to be lifted up to some degree, otherwise the bottom holes of the container won't be exposed. I discovered this German company called Hakon, who produced this military-level lifting device. I approached Hakon and they put me in touch with their Netherlands partner company. They sent me this brochure of the exact same system that was depicted in the video. And I was surprised by how expensive the entire system is. It consists of 4 pieces and altogether costs nearly 10,000 euro, which is the entire budget of my project. So I asked them if they have a cheaper option, and they sent me another one. And that still costs more than 2,000 euro, which was still over budget. And I asked them again, oh, do you even have a more simple one? They said to me, finally, this most minimal setting that costs still 1,000 euro. I asked for a sponsorship or some sort of partnership. They said Hakon, the company, is not interested, but at least they could round the price to 1,100 euro to show their support. Some symbolic action, so that was the price set. I also discovered this company called Bouting Technology, who develops vehicle salvaging lifting bag. So it comes in different sizes. They normally use multiple of these bags to carry back fallen off vehicles, like in this instance it's a bus, and to push back up. So I thought potentially I could use just one of them, because I can only afford one, to roll a container. So this is the streamlined process. This is finalized, but it took me quite a while to really finalize it. So in the 1, there's a container, and 2, you attach the cheapest lifting spindles into each bottom corner of a container. 3, you complete 3/4 of the wheel structure. 4, you push in the lifting bag underneath the container and also pull out the lifting spindles so that the wheels it's standing on its own on the ground. And 5, you start lifting this bag and then it's tilting. And 6, you make the container upside down so that the bottom is exposed. Because I'm using the lowest level lifting device, that I could not lift up a container high enough to attach the bottom beam from the beginning. Well, actually, for me personally, as an artist, it turns out to be aesthetically more interesting, having to flip a container to complete the system. That's my favorite part, actually. Then 7, the wheel is complete, and 8, you start rolling the container again by using the same lifting bag. So this is the deassembling process. So 1, you have a complete wheel. 2, you route the bottom wheels of a container so that it becomes again a 3/4 of a wheel structure. And 3, you somehow tilt the container. 4, you insert this lifting bag, inflate it again in order to catch this container. And 5, you put the air out and sort of gradually coming down and onto the ground. And 6, you attach the lifting spindles again to the bottom of the container so that the wheels is up from the ground so they can start taking off the wheels. And 7, you have just spindles, and then 8, it's everything is gone. The process of deassembling was part of my thinking, because if you can assemble something completely manually, then you need some sort of machinery to deassemble it, and it doesn't make any sense. So I wanted to make the entire process of assembling and deassembling, they both needs to be manual. So this is the possible impacts that the container would have when it's released onto the ground. So this is one of the initial drawing of how container system can be built. It shows that already how the connection would function. There are 8 pieces in a wheel. It's because it's going to be too heavy for one person to carry if it's longer than to some degree. So it's divided into 8 pieces per wheel, and each piece is connected by this metal plate, 8 bolts. There's some flexibility measure taken in the connection. The way the holes of the plate also on the beam are slightly made bigger than the actual bolts themselves. I talked earlier, even standard containers sizes can vary slightly. So this is how flexibly the system can be adapted to each different size of a container corner. There already the bottom twist lock and the side twist lock depicted in the image, but there's no way that shows how the twist locks should be welded or connected to the structure. So I didn't look into further details about how the connection precisely works at this stage yet. So I have to
work out how the connection precisely would function. So I carried out some testing in my studio. How would this sort of pressure works when all the connections are sort of attached to a container hole, a corner. And this is like when a pressure is put only horizontally, and it was quite loose still. 2 Twix locks are not colliding, well, just about not colliding inside. And this is the only vertical forces put into this structure. That's the most probable sort of scenario. And in this moment, the entire structure became rock solid. This solidity sort of shows that, oh, this locking system could function. So I used this software called Inkscape, which is a vector drawing software, to make this planning of the wheel, because I could not handle CAD software properly. This is how the corner connection could possibly function. Then when I tested the real container mock corner and then real twist locks in my studio, they also measured where this twist lock and then side twist lock was located within this container corner, so that I can precisely plan milli-level accuracy. I also tried to use this CAD software. It did not really quite work out, but I managed to make this mock model in 3D. So I had this how I should cut the bottom of a container issue. So there are 2 different scenarios that I thought would be the case. The one is that equally divide all the beams, not equally divide precisely, but the second one is actually just cut in a horizontal way that it stands better on the ground. So this is how the cutting line could potentially function. And the blue line is the most general sort of cutting line. And the first one is the horizontal cutting line, quite up. The second one is the middle, and the third one is bottom. And then, of course, how you cut this wheel affects when its entire system is being lifted and tilted. It changes the rolling sort of tipping point of the system. It really kind of took me a while just to think which method is the best. So in the end, I came up the most general way of cutting would be the best, considering when container is being at the tipping position, possibly function the best. This is how this scale will look like. So now I hit another problem of whether the whole system that I designed could hold up itself or not. So I have to turn to civil engineering faculty of TU Delft. My collaborator put me in touch with this guy called Milan Belkovic, professor in steel structure. He initially said he was going to charge €300 per hour for the calculation or the consultancy. After that, sort of we tried to secure additional funding from some port-related organizations, and we managed to secure up to €2,000. And by this moment, somehow Milan said, well, he doesn't want any money for this. Suddenly said that. So he made drawings of how the system should be functioning. And he actually said that the type of connection that I imagined is not the best type of connection, he said. It's quite vulnerable, according to him. He said like a way of bolting in the bottom could be the best. And I asked him, what are you going to do with bolts sticking out of the surface? You cannot just leave it. And he said there's a way of using a bolt that sort of gets embedded into the surface. And this is sort of another drawing he made, which I did not quite understand. So I had to make another drawing and ask him, do you actually mean that like this? And then sort of he says, yes. So I actually attached another plate onto a surface of this wheel and then sort of bolted it in 2 sides together. So he asked one of his PhD students to do simulation of how pressure is put on the wheel when it's deployed. Load case 1 shows that the wheel structure is standing on its own. It's only 3/4 of the wheel, it's because more vulnerable. So they decided to actually calculate it in the most pessimistic scenario. So when it's standing on its own in load case 1, all the pressure goes up. Load case 2, when it's upside down, again the pressure goes all up. And then in load case 3, I hope this is correct direction that I popped. It shows that how the wheels tilted, sort of where the pressure goes. But in the end, like Milan actually said that after all the simulation, he actually said, well, in this red character, it might basically collapse. So please keep the safe distance away from the system when you test it for the first time. All right, okay, so that's good to know. So this is the finalized drawing that I actually sent into my supplier in Elst, in the east of the Netherlands, who I was introduced to an art institute who I worked with. Without this introduction, it would have been so difficult to find them. Also, I could have been easily overcharged. Anyway, I'm trying to design the system in a way that it's so simple for the manufacturer that they cannot make any mistake. They had another supplier to first bend the steel using cold bending method, which has less tolerance. Someone said that actually there's only 1 millimeter tolerance. If you design something, then it most likely turns out to be the same. I had a trouble with the supplier about sticking to the deadline that I gave him. they basically kept ignoring the deadline because it's so important, because I have to book the testing site, and if it's delayed I have to sort of rearrange everything, it might cost more money and stuff, so I have extremely limited budget. So I just kept telling them that, well, I have to really, this is the deadline, but sort of I have to sort of pressure them. What I did was, it's a company run by a couple, so I went there first thing in the morning. Before they arrive, I was already there in their office. So I gave them the feeling that this guy will not back off unless we do the job properly. This is something sometimes I do as a sort of pressuring method, to be present, really. And it worked out quite well. And someone once told me that I tend to wind up people for no reason, just for just being somewhere. So I'm good at somehow this irritation wherever it worked out, and I got fire on their back or something, and they really started to seriously work on it. So that's the method worked out. But of course, afterwards, I brought them some Dutch donuts to the supplier to encourage them and so on. So I didn't forget about also treating them in a good way after sort of giving them some pressure. This is when I visited their factory. They're cutting the plates with water jet. They designed this cat for me because I couldn't, which is a shame. So this is all the beams. And this is the connection that I designed. So they're using this MOOC container scaling. This is how the entire sort of wheel looked like. And this is Remco from this company. He did a great job. He only finished in 2 days actually, because everyone else was on holiday and he was the only one. And he finished in 2 days. So this is how we loaded my studio mate Florian Brackmann's van, and I'm happy with the result of all the beams. We also turned to another supplier called Bouting Technology for this lifting bag, and we put everything in. So Florian, we just put everything together, and so Florian's parents happened to live close by. So we went there for dinner, and also they asked his dad to check the car if it's not too heavy around on the waterway, and then he said, well, that would be probably fine. So then we decided to go for it. So not only finding right suppliers and providing them with correct drawings and planning, I also have to find the experiment site, which turned out to be quite difficult also, because hiring a space is quite costly in the Netherlands. I needed some degree of flexibility as my planning around completion of all the parts and getting all the parts together, still booking could be sort of shifted. Luckily, I made contact with the Future Mobility Network, which is a facilitator of autonomous driving and those experiments, which I already had a connection with. I consulted with a guy called Alvin Bakker, and he put me in touch with the Nagarjun Reddy, who worked for Research Lab Automated Driving Delft, which was within this Future Mobility Network. Eventually, this Themis took over Nagarjun. And then finally, sort of the Tim Jonathan from the Green Village, they put me in touch with him. So I got this experiment site next to the Hyperloop within the Green Village. So the Green Village is a sort of experiment site, experimental projects, housing, mobility related, autonomous cars and so on. So they host high risk projects. So that also was suitable for me. In order to use the Green Village, which is within the TU Delft, I had to go through some bureaucratic process for my project to be registered within the system. And one of the documents I had to fill in was this Research Lab Autonomous Driving Delft, this document, basically explaining about what the experiment is all about. And luckily there's a section, especially like this mode of the operation, the vehicle, tick the relevant operation. There are 4 options because they're Research Lab automated driving, right? So completely automated, mostly automated, but will take over when they're required, remote controlled, joystick control manually, and they have this option for me, completely manual. So that was the option I had to go for. And I also have to fill in another document provided by Research Lab Autonomous Shipping, because they have something called experiment safety analysis. So I have to roughly just give them what kind of potential risks and what kind of level of danger, from my experiment, which actually had no idea about. So it was quite difficult to actually make this document. Also have to make a research question out of my project. So I found this interesting term called cargo rotation, which doesn't mean about actually rolling the container, but it means how they can sort of locate empty containers in a way that can be sort of utilized in the most efficient way. So when the ship arrives somewhere, then it leaves an empty container, and how they can be sort of moved to a different location for shipping some stuff again using the same container, so on, etc. But it was kind of half joke. So a novel method for cargo rotation, and this, of course, the cargo is rotating the literary. So that was the width anyway. My collaborator from TU Delft, he had a connection with a company called Katena, which is a Rotterdam-based container hiring selling company, and they decided to sponsor this project, which means I didn't have to pay for the hiring cost of the container, I only have to pay the transportation cost, and that saved me almost 1,000 euros. So after the container was installed, experiment site, we delivered all the equipment inside the container, trying to be ready for the experiment next day. So this is all the list of equipment that I had for the experiment. 20-foot dry container, lifting spindle, lifting bag, hose, manual pump, container wheel beam A, container wheel beam B, M12 bolt, M12 nut, M12 washer, ladder, 30mm wrench, 30mm 12-point socket, 90mm wrench, 90mm 12-point socket, 90mm 2-handle socket wrench, extension bar, torque ratchet wrench, ground protection mat, scissor jack. So I have a lifting bag here, and the pump and the ladder, lifting spindle, all the tools that I needed, and the beams, side beams. This is how it was welded, and this is the bottom twist lock that's attached to the foundation structure that's weldable. I'm trying to insert the one of the lifting spindles to the bottom container corner. The beams were designed to be about 25 kilograms, which is the legal limit one person officially can carry in the Netherlands. Although the system was designed for one person, ideally you better have an assistant person, at least one person. The process is way easier. This is the corner design. There's a plate on only one side because the thickness of the plate is roughly almost a centimeter, so this is quite heavy stuff, so you don't have to put plates on both sides. 3/4 of the wheel complete. Insert the lifting bag underneath it. Pull out the lifting spindles so that the wheel structure is standing on its own on the ground. You start pumping the lifting bag, and the lifting bag is functioning. This bag is something what they call a low pressure bag, which means the amount of energy that you put into the bag does not change as it gets bigger. So, but it's still quite laborsome. So I soon got quite tired and have to use the whole body to keep lifting. It reaches the point of almost tipping, and this view is quite spectacular. Keep lifting, but at some point there's no grip to it anymore, so I have to kind of, some people help me trying to roll by just pushing, which I think is quite dangerous. But eventually, so you keep shifting the bag and just trying to make the container upside down, like I was streamlining. And here I hit an unexpected problem of fitting into the last parts of the wheels, the 3/4 of the container wheels. Because when 3/4 of the wheels attached, of course it's upside down, and it's on the side. There's a lower pressure given to the beams, and the steel is deformable, so there's not enough space to be able to fit in the last part. So basically have to release the weight from the wheel structure so that you can put the wheels back on. But some of you might think this is not manual. That's correct, because we're using a forklift. But there was a discussion, we had a discussion whether this process could be also done manually by using a lifting bag, putting lifting bag in the one side of the container and then do manually. And then we concluded that this is doable, but we didn't have enough time, so we'd have to rely on this machinery. But provided that it was also doable manually, we carry on with this method, lift up and release the weight. So we had to use this car jack, unexpectedly also some pieces of wood to really push out the beams to make it circle, tighten the bolts and then completing. But also that the rest of the bolts also had to be loosened again, because it's about the entire wheel. And so like if you tighten one part of the wheel, the rest of the part doesn't just come together. So like maybe there could be space for improvement in this, how more easily this wheel can be fit all together. Finally ready for rolling a container. Yeah! And you start pushing, pushing and pushing, and this takes absolutely ages. And then finally this moment came. So the next day, also have to, the assembling process, like I said earlier, had to be also done manually. Trying to straighten the container wheel structure, and then using the lifting bag as instructed in the process, and use as a catching bag to catch it and lift it back down onto the ground. And this impact was actually smaller than we expected, so which was good. And finally putting everything back into the container, and that was complete. So thank you very much for my presentation.
That was fascinating. I was really impressed by the clear leverage that we had going on with the system. And I guess the first question, we've had some nice feedback in the discussion list while we were watching all these movements of the container. And I think the first question is, what's next? You know, what do you have for ideas for next steps for this method for container movement? Had some nice feedback in the discussion list while we were watching all of these movements of the container. And I think the first question is, what's next? You know, what do you have for ideas for next steps for this method for container movement?
Sorry, I was just reading the chat, and next process was it? So sorry, what was the question again?
What's next for the
oh yeah, okay.
For the project?
So I had a discussion also with the PhD researcher from Ethiopia, interestingly enough, and there might be application there actually. So because in Ethiopia apparently the labor works completely different to a Western country. So he told me that the more labor intensive, the better in that country, because it leads to more employment. So you know, for example, of course, I designed the system for one person, and it's of course like I was focusing on in the Netherlands or Western country, the less people employed in the system, the better, because it is to cost cut. But there, like it's maybe potentially you can employ like 5 or 6 people for the system. So that could maybe, yeah, the government might be happy for it. So yeah, that could be one of the steps.
Thank you. Yeah, so labor saving or labor shifting from machines to people is the idea.
Yeah,
wow.
It's zero emissions. Yeah.
Yeah, yeah, of course. So I was curious, you mentioned a little bit of computational modeling that was done by your colleagues for some of the load, you know, in steel. But I was wondering, even early on, were you doing any physical modeling whether it's computational or just pen and paper, but were you doing modeling of things like, mass and weight load and that sort of thing?
I did not. So that's the kind of, I think, a strange maybe way of working, because maybe no, and this is something. Also, like I sort of had a discussion with someone who studied industrial design, and he just kept telling me that, oh, you need to make a scale model, and that is the only way to make a system work. And you just keep thinking that you can never sort of make a system that actually functions. And when I was kind of doubting that method, because it's in the end, at the end, I said in the video also, like it's in the end, it's all about the real connections, and the real connection doesn't work. Well, if the twist locks collide inside container corner, then it doesn't work. So it's all about the real object. So I kind of knew from the beginning. So I just kind of really sort of stick to the real object from the beginning, and didn't make any kind of scale model.
Right. Very interesting. You mentioned one of your colleagues at the university helped you with those plates and the bolts and the countersinking of the bolts. And so obviously there was some expertise there that you benefited from, someone that knew something about industrial design. One thing I was curious about, related though, is your choice of steel, your choice of materials, and even those beams. Were those beams fabricated custom, or were they the rails? Or were they rails that existed and they just had to bend them to the right extent?
Well, I mean, and also my friend architect guy also told me that, well, if a business develops a system like this, it would probably cost them 5 times more money to do that. So, as an artist, I always work with limited budget, and then somehow have to sort of go for the cheapest materials from the beginning, and could never make a mistake. And that was just for me, the decision was quite apparent to go for this material, and because it's what's cheapest precisely. And then the weight was a problem. Someone told me that it could be like made out of like titanium or something, of course, and it's lightweight, more, like the stronger, but of course you can't afford it. So it's something that's it's affordable, and also just the material option was kind of made in this kind of way.
Yeah, you mentioned the need to have each piece be 25 kilograms or less, and obviously if they were lighter, then you could have a little more efficiency in the labor of setting them up.
Yeah, exactly. I mean, that was also that was the only part. If it's really manipulate, if it can be manipulated by a human or not. So that's also because it was sort of human-centered system. So that otherwise just kind of went for the best, cheapest materials, and
Okay. The other thing I was curious about, these are is rail transport, because obviously rolling along on concrete was not going to be, it wasn't going to go as evenly as you wanted to. So obviously shipping container yards do have rails for regular trains, to bring things in and out. But were you thinking that there would be a rail system that would be wide enough for this type of transport?
Well, I mean, for me, like that was the sort of exact sort of question that I wanted to sort of ask, in a sense, the people or society. Well, because I don't think the old streets should be dedicated to cars in the first place. Because they think about it, the reason why a container is shaped as it is because of how the roads are laid out. And it's all the streets and roads are designed for the cars. So as soon as there's no cars anymore, there could be, the roads can be sort of made completely different, right? Like, whatever the really elastic field, and you can just go across, in whatever way, so I think, I'm kind of looking far ahead, in the sense that the sort of this system can be somehow utilized at some point.
Yeah. So I was thinking, you mentioned Ethiopia, and I'm thinking if they were having a lot of labor to move containers, then maybe they would put in a rail system with this wide width to accommodate the containers, so that they could more efficiently move them back and forth. And that would, of course, I think it would likely reduce friction as well by having a rail system that roll over. I'm curious, I'm sure you got to see a number of containers, and there is some variety in containers. So, two things. One is some of them have refrigeration units that will shift the weight. In other words, there won't be an even weight. And the other is a lot of shipping containers have corrosion, here and there. And so I wonder if you looked into sort of these types of variations in shipping containers, or if that would be a future activity.
You mean to make a system for different kinds of containers, or?
Well, just the practicality. If you have a shipping container that has a refrigeration unit, then it's not going to be evenly weighted, side to side and top to bottom, as an example.
Yeah, I think I don't know what I say. Well, so I made a system like a sort of, well, it's kind of strange the way of working, but this is physical, of course, and it appears all functional and everything. But I made this system in a way that sort of it's not functional in a sense. And that's exactly how sort of I'd like to work, sort of to keep sort of how I'd like to sort of keep this project is like sort of in a sense that's for me, like that was the whole sort of point of working physical. Sort of it looks sort of so realistic because it's sort of function, but it's sort of in a sense it's fictional in a sense.
Yes, a proof of concept. Yeah. Well, thank you. This has been a fascinating discussion, and the idea of having using the basic levers and force and manipulation to move such a tremendous object, I think, was inspiring to us all. We're out of time. I'd like to say thank you again. It's been wonderful having you, and I appreciate you being part of Hackers on Planet Earth.
Yeah, thank you very much for inviting me for the book. Bye-bye.